Good afternoon, ladies and gentlemen. I would like to present our project with name Smart Campus. I'm from University of West Bohemia, and before I start my presentation, I will introduce my university, because we are a relatively new member of the IQRF Alliance. I'm from Faculty of Electrical Engineering in Pilsen and Department of Technologies and Measurement. Of course, we are members of Regional Innovation Center for Electrical Engineering with short name RICE, not RICE, please. And the RICE was founded by budget about 25 million euros. That means that we have very new and high-tech technologies in our research center. And our focus is, by the way, on printed electronics and IoT. Here is a competence roadmap of RICE, and we are focused to transport system, power engineering, and material research, where I am a member. Our activities connected with IoT and Industry 4.0 is printed and flexible electronic, passive sensors or transistors, smart textile. I think we are very good in smart textiles. It means that is some textile with electronics included inside. Vapor and gas sensors, chemoresistive or electrochemical development, industrial deposition technologies like aerosol jet printing, and flexible systems. On the pictures you can see some outputs of our projects. We have some very much of projects, international and national projects. And one of the most known output of the project is a smart fireman suite, which can measure temperature, humidity, and some gases, have interconnection with commander control suite, and can measure heart rate or temperature. You can see the smart glove in the corner. It's able to measure temperature on the surface and remote temperature of the hotspots. There is the indoor localization system implemented in the boot. It's for indoor localization where you missing the GPS signal. It's one of the most known projects. Then our target applications and output of other projects are, for example, smart bed sheet, including electronics for detection of patient on the bed, or can measure humidity. Next things, for example, textile electrodes and heating textile. We have good experience with printed and embroidered antennas too. It's very good for IoT applications, for example. We developed some hybrid conductive sewing threads, and using it with sensor elements. For example, we can embroider temperature or humidity sensor on the textile. Here is some examples of printed electronics and sensors. And this is the output of our project with the name FlexPrint. There is some electronics implemented on the PET foil. It's a flexible tag which can measure temperature and humidity, and it's fully flexible with including batteries, and can transfer data by RFID technologies. There are some examples of printing antennas. On the left upside is aerosol jet printer. It's a very nice printer, something like standard inkjet printer, but this one is much more expensive, and we can print about 10 microns lines. And on the downside, there is embroidered and printed antennas. Well, now I'm continue about the Smart Campus project. This is the relatively new project which we start, and we think that we have Smart Campus like city, but it is smaller than city. Yeah, we have the environment there very similar to the cities, and we decided that we will do from our campus, Smart Campus, something like test polygon or living laboratory, microcosm of a city. I think this Smart Campus is opportunities for all. First time for university, because we have students, we can put the students to the campus, and they can do the diploma thesis there, and getting and growing up their knowledge about smart technologies. Of course, this is a chance for companies, because if they have some smart solution for smart city, they can put it to the Smart Campus and test it there, or upscale there this solution. And finally, this is very good opportunity for the cities, because cities today in many parts, they don't know which solution is for the best. They doesn't know, but they can go to the Smart Campus and see all the things works there together. And of course, there is possibility to do some projects together, city and university and companies. Here are some informations what we do. First was organization structure, communication infrastructure, and putting smart technologies and implementing to the Smart Campus, and partner contracting. About organization structure, we have 3-level structure. The top is at the university level. There are 9 faculties for research institutes, and some organizational units. Next level is faculty level, and third one is on the each department at the faculties. We collaborate with some companies to do infrastructure in the Smart Campus. For example, Sigfox network by SimpleCell. We built up our own LoRa gateway in the Smart Campus, with collaboration with RWTech company, which provides LoRaTech solution. It's something like Lego. If you want to have your own LoRaWAN network, you can build it up without problems. And of course, we collaborate with Pilsen City. Of course, we built up IQRF network in our Smart Campus, and we are waiting now for new modems for narrowband IoT network. Next part of infrastructure in progress is changing campus street lights from the old system to the new power supply 24/7. It brings us new opportunities to put there, for example, Wi-Fi hotspots and other IoT sensors. We are in collaboration with Technology Center PSEC, and we built up a smart campus cloud in the environment of our university. The same or very similar cloud system, which has colleagues from TCP. Our next steps are in the smart parking. It's in the progress. We have contracted some companies like ČD Telematika, Radek Pechman, and Certicon, and we are starting the implementation of different parking systems, and then we would like to integrate them together all and put the data to the cloud system, and the next steps will be open data and so on. Next things in the progress is, for example, in collaboration with Tesla Blatna, smart city sensor. Michal Vodnar introduced this type of sensor. I only say that the part of the electronics in the gas sensors we developed and designed at our university. Yeah, it's inside this sensor. Next example is a sensor for temperature, humidity, and pressure, which we developed for LoRaWAN network for company RVTech. And very interesting thing about this sensor is the idle consumption is under 70 nanoamps. It's very low consumption. That's good for the IoT technologies. And this type of development is on the market. We developed it last year, and this year it is on the market. Last things what I would like to mean it's a new IoT platform for IoT. The name is CatCube, and this very small part has some processor Murata there, and it has connectivity to the LoRaWAN, or of course it can have connectivity to the IQRF or Sigfox infrastructure. We start some social things like web pages and Facebook and Twitter and Instagram, where we show what we do, and of course we are still searching new partners for collaboration in our project. If you want, you can join us now or visit our web pages. Thank you for your attention, and if you have any questions, feel free to ask me now or later on the booth in the foyer. Thank you.